Greetings everyone, this is Non-Expert here, back again with another video. Today we are going to be solving problem number 16 of our 30-day LeetCode challenge, and the problem which has been given to us today is valid parenthesis string. This is a pretty common problem on LeetCode, and if you want to try solving this problem on your own, feel free to check out the link given in the description below. So problem description is that you've been given the string containing all three types of characters, which is a left parenthesis, a right parenthesis, or a star. Or you can sort of think of it like opening brackets, closing brackets, and a star. And you need to write a function to check whether the string is valid. And we define the validity of the string by these rules. And the rules are that any left parenthesis, which is the left parenthesis, must have a corresponding right parenthesis. And your right parenthesis must have a corresponding left parenthesis, and left parenthesis must always go before the corresponding right parenthesis, which is like, if you open a bracket, you have to close it as well. A star could be treated as a single right parenthesis or a single left parenthesis, or even as an empty string. And even an empty string is sort of a valid value which can be sort of given in. So I believe like most of you would have tried to solve this problem before, but the only change that you would have seen is that there's a star over here. Um, Essentially what we have to do is when we have just simple brackets is that you maintain a stack and you keep on popping out the values. If you encounter a closing bracket, you check whether the opening bracket sort of is there. You basically try to see whether this rule is valid or not. Sorry, this rule is valid or not. Oops. Yeah. Anyways, so you've been given a few examples over here, and this is true. As you can see, it has a opening bracket and a closing bracket, and the way you can sort of validate that thing out is by saying that, hey, the stack which I have that I'm sort of talking about, the stack which I have is going to be empty. And again, if you don't really understand the methodology between a stack and how I'm sort of thinking about using it, that's fine because we're going to be using that approach while sort of moving forward. So we've been given a few other examples here. Feel free to check them out. And what we'll do is we'll start with the base conditions. The base conditions is just going to be like, hey, if s is equal to an empty string, you can basically return true over here because an empty string is valid. And now what we want to do is we want to maintain a stack. So again, like a few properties about a stack, whenever you do a pop operation, it needs to happen in O of 1, and inside list, whenever you do a dot pop, it sort of pops out the last item in O of 1. Also, it has all the append operations and all that stuff, so we're still following the leaf-for property of a stack as we're sort of moving forward. So what we want to do is we want to basically, go through each character inside our S, which is basically our string. And whenever we encounter a opening bracket or a left parenthesis, whatever you want to call it, what you want to do is you want to append that to your stack. So I'm just going through a simple example of how you would do it when you don't have any star values and all that stuff, and then we'll sort of build out our entire algorithm using that base. So else if you have a closing bracket, then you basically have to check whether there is a stack or not. If there is nothing, if the stack is empty, then you return a false because, well, your right parenthesis needs to have a subsequent left parenthesis for it to get merged on. If it does, then what you do is it's pretty straightforward. You just do a simple stack.pop. So if you say, hey, if there is a stack over here, then you do a simple stack.pop. Pretty straightforward so far. Not that many complications. I know you can like do this a little bit better as well because, well, you could have um, basically you could have a bunch of other stuff also. You can make this code look a lot more prettier, but that's not really the point because we're gonna like build out on this logic. So again, this is like not the most scalable way of doing this, but I think this thing should work if there are no stars. Now we need to sort of code out a logic for the stars. And since we're already sort of thinking about stacks, how about we think about what a star really represents? A star could represent either a left parenthesis or a right parenthesis. In which case, if you have a right parenthesis, basically what you want to do is you will want to, like check it with a left parenthesis. It's pretty straightforward. If you have something like this, you know for a fact that the star is going to be a left parenthesis, so you have left, left, right, right. So that sort of works out. If you don't sort of understand like what you want to do, you just want to like close things out eventually. But if you have a right value, and if you have a star, And what you can think about is a star could be represented as a left parenthesis in that scenario when basically you're trying to look for um, whether there's a right here or not. A little confusing, but that's to be that's to be taken for it's going to happen. Um, so if you sort of think about, so we've been given an example which has only one star. If you think about multiple stars, that's where it becomes like really tricky to understand. So what if we have another stack which could just maintain all these values? What if we have something like a stack which star stack which just contains the values of the stars? And what I'm going to do is I'm going to just update the logic a little bit, and I'm just going to say that, hey, instead of me just appending ch inside our stack, we already know that the stack is going to contain, I mean, at least this stack is going to contain nothing but opening parentheses or left parentheses, and this star stack is just going to contain stars. What if instead we sort of contain the indexes? And that intuition is sort of really hard to get, but once you sort of think about why we're sort of storing it, um, it becomes a lot more easier to understand the necessity of storing indexes inside your stack. So the reason behind why I want to store it inside, basically I want to store an index inside a stack is because, well, there would be a case where we have nothing but opening brackets and we have a bunch of stars and no closing brackets. So all the stars needs to be transformed into basically um, into a closing bracket. But you still need to understand like which index does it really belong to, whether that thing is valid, whether the star that you're sort of converting into a right parenthesis is not coming before the left parenthesis. Um, yeah, so basically what you can do over here is you can sort of add a few else if conditions, which could just be, hey, if you have another star over here, well, in that case, what I want to do is I want to append it inside star stack, just the index, I want to append that inside that. Um, if there's no stack, then I also want to check whether there's anything existing inside the star stack. So if the stack is already empty, that means that there's no more left elements. We've come to the right. This else block sort of comes when you're inside the right, when you have a right parenthesis. So if there's nothing inside the stack, then you also have to check whether there's anything inside star stack as well, because the star stack could be represented as a left. So right now we're just going to think about converting those stars into the left, and then we'll sort of think about converting them into the right. So if you don't have any stack, then there's no meaning of going through a store pop operation. But what you can do instead is that you can say that, hey, if there is, I mean, if this thing sort of breaks out, then that's okay. I mean, I think that's fine. You can sort of put a try catch. I don't think it'll break out, but eventually I'm just assuming that, hey, star stack is gonna have like some value inside of it, and you just pop out that value because you're thinking of that value as um, you know as another value. So um, yeah, I think this is fair, because otherwise, if both the stack and star stack are empty, then this return false will happen. Otherwise, you're gonna have either one of these conditions coming true. So effectively, what we've done so far is that we've sort of used the star stack and converted or sort of mashed up the right parenthesis with the left parenthesis and with the stars. Now, what we want to do is we want to check whether the stack is empty or not. And well, we're sort of already checking for that already. But we want to check whether the stack is already empty. If it's not empty, then we want to check whether star stack has any role that can play. And that's where the indexes will sort of come along. And it's a simple while loop, to be very honest with you. It's not really that complicated. You just say, hey, while either one of the star stack or the stack has some values inside of it. If it does, what we want to do is we want to do a pop, right? And we want to check that whatever stack has, it's it's basically it's basically greater than the value that's inside star stack. And let's just quickly. I mean, sorry. Um, Basically, what we have inside your star stack should be. I mean, whatever's the last element inside your star stack should be greater than the last element inside your stack. So you push in a condition which is saying that, hey, if your stack.pop, which is basically give me the last value, is greater than star stack dot pop, basically you're saying that, hey, inside my stack, the last element or the last index which we sort of fetch out is actually greater than star stack. That would mean essentially what you would have is something like this. And well, right now sorry, this is wrong, like this. So essentially, there is no way that we can sort of convert this thing to, make it a valid string. So what we want to do is, even if we do this to the thing, it won't work out. So in that case, what we want to do is we would just want to return false. And basically the while loop keeps on running till you sort of, come across either the stack finishes or your star stack finishes. Uh, and if your star stack finishes before your stack, then this return statement is going to return a false. If your stack finishes off before, then you don't really need to worry about star stack. The reason being the star stack can also have, or rather, a better representation would be a star, a asterisk or a star can also be represented as an empty string. And that's basically it. I think we've got the code right. Let's go ahead and try to run this. I know where this thing is running. Let me just see for a quick sec. Run this code, and this is running fine. Let's just go ahead and try to submit this. Hopefully this should get submitted. And awesome, you can see that the solution's been accepted. Space-wise, not the most optimal solution. I'm sure that there are multiple variations to this problem where you can solve this problem in a much more efficient way. But overall, we'll just do a quick recap before we sort of end this video. So a quick recap is we started with what we know. So we know how to use the stack for valid parentheses checking. And now what we did was we included star stack, and inside the stack itself, just placing in some arbitrary value which is just constant throughout. We're placing in the index which we can use later on. And inside what we do is we sort of take care of all the left inside the star stack. We sort of take care of all the values which can be represented as a left parenthesis, and that's sort of happening over here. And then we sort of take care of all the right parentheses which could be made, which we sort of take care of in this while loop. And basically we're done, and then we don't really have to do anything more. So that's it for today's video. If you had any doubts, if you have any comments, do leave it in the comment section below. I love to hear from you guys, and I try to respond as quickly as I can. I know that this concept can be a little tricky, and for me as well, like full disclosure, when I was thinking about it, I just thought about the stack, and I sort of took a lot of time to just think about how to do the star stack implementation and use the indexes to sort of come across those things. But that was just me trying a bunch of things, and then I sort of came across this thing. So if you didn't sort of get the indexing approach at the very beginning, that's okay. If you sort of try it out, you'll sort of get the hang of it. Um, but but yeah, that's basically it. So again, like if you have any comments, leave it in the comment section below. And if you did like this video, do give a like and do subscribe to our channel. We have discussion over here, and we would love to have you on board with us. And if you've already subscribed, you're awesome. We all know it. And have an awesome day and stay safe. Thank you.